Okay, in the last section, I gave you a basic overview of reliability and validity. In this section, we're going to hone in on consistency or internal consistency of the test. Okay. Internal consistency measures the reliability of a test. And this is solely on the number of items and how those items correlate with each other. So, which means we have to have a Pearson someplace along the line, which we will discuss in the section named correlation. And basically what a correlation does is it compares the items to all the other items. So if you have 20 items, each of those items will be compared to the other 19. Now, it's very, very difficult to do this by hand, so we do this through different kinds of computer programming. You can do this with an Excel, although it's long and drawn out. One of the easiest ways to do it is to do it through an SPSS. And basically you plug the numbers in there, and you have to know which numbers, of course, to push. So on an SPSS, it is a program which one of the functions, you have to pick out the function, is to do a correlation. You have to tell it which correlation to do, but generally speaking, we're talking about a Pearson. Now, the scale is measuring a construct. What exactly is a construct? A construct is an overall theoretical idea. So, for example, teacher dispositions is a construct. It is a construct that we have a certain belief pattern as to what teachers are supposed to be, how they're supposed to act, and the beliefs in behaviors that good teachers process and practice. But that is a construct, okay? It's an active theory. And to practice this active theory, we want to find out exactly how do the items in a test measure this construct. And we do that by looking at the internal consistency. Now, and I have no idea why we have this little bar down here, so we'll just put up with it. Cronbach's alpha is one way, and it's very highly used. And this is one of the alphas that we typically use. According to Cronbach, these are our below 0.60. Now remember, it goes from -1 to +1, and we'll discuss this more in the correlation section, unless you've already seen that lecture. But 0.60, anything below that, don't use it. According to most experts, 0.60 to 0.7 is okay. Probably still not your best bet. 0.70 to 0.80, it's very good. It's getting up there to where you can be be much more comfortable in using that test. Anything from 0.80 and up is considered excellent. Now, in item to total correlation, so you're going to look at that item and then the total correlation. So you're going to have, the Cronbach is going to give you item to item, but it's going to give you a whole number, okay? And so then it's going to average all of your item to items together, and that's the number that you're going to use. But then you have the item to the total correlation, and a 0.30 is the minimum acceptable item. Now you see that it's going to be a little bit different because in the whole group, you're looking at more than one, and so you're going to lose a little bit of power as you use as you use more and more of them. So you need to have a higher number to make sure that those correlations come together. But if you're only looking at one item, you just want to make sure that those items are useful. Now, internal consistency, we want to see what are the estimates. What are they a function of? They estimate the number of items, they're a function of the number, and they're a function of the average intercorrelation that we just talked about on the other page. So each item is an observation of behavior, different behaviors, internal consistencies, strengths of the relationships, and the more that we see of it, the more we have to observe. Okay? Thus the larger numbers. The intercorrelation. This is the extent that each item represents the observation of the same thing. So if we have a large group and we're looking at math, we want to make sure that double-digit addition correlates decently to the overall number. Now, we want to go back over this test, retest reliability. And again, the key math is an excellent test to use as a backdrop. This is a trait that's being measured, and it has to be stable. So it can't really change. So that trait, again, double-digit addition, 2 plus 2 or 20 plus 20 should always equal 40 if we're just adding double digits. So the trait remains constant. The readministration of the instrument should result in scores that are similar to the first score. Now, remember, it's important to conduct retests shortly, but not too shortly and not too long after the first test, because we want to be able to control for influencing variables. Now, what happens if it's too soon? Students may remember test items, this is called practice effect, and score higher the second time. If it's too late or too far away from the first one, you're going to have a greater influence of time variables. Learning, maturation. Maturation is huge because this is basically looked at as experience. Because if you look at a child in, say, 3rd grade at the beginning of the year, and then look at that child again at Christmas, really? We've got two different kids here. Because children mature so fast that sometimes that maturity rate, we have to really keep up with it. I remember when I would leave when I was teaching middle school, and we would leave at the end of the year, and we would look at these kids coming through, and then the same young person, boy or girl, would come through the halls as a 7th grader. And some of them had grown 4 or 5 inches over the summer, but the maturity that we noticed was phenomenal, generally speaking. And so the maturity, that's a very, very important variable to take account of. Also, looking at alternate forms. Again, the key math is a great test to look at. We have alternate forms. There's form A and form B. And they've been found to be reliable, consistent, valid, and they pretty much test the same things on the same pages, just different questions. The advantage of having 2 tests with the same difficulty is it can be administered within a short time frame and you don't have practice effects. Because it's a different test, you're asking the same concept, you're asking a different question. So you may be talking about ducks the first time and counting the difference between big ducks and little ducks on one question, and the same concept might be looking at horses and cows. We're still talking about animals. You know, we were talking about birds, now we're talking about animals. Same concept, we're still asking them to add those things. Now, other consistency measures, we have a split half reliability. And this is when it starts getting a little bit hairy. What do we do when we don't have the option of using, as in this one, equivalent forms? If we don't have equivalent forms to use, sometimes what we can do is we can cheat a little bit. All right, you can either split it right straight down the middle and take the top half and the bottom half, except the problem with that is often the top half of the questions are different than the bottom half, and so you have to make sure that they all load into the right places in the right ways, and so that can be a little bit difficult. Because especially say you're giving a math test. The first part of the key math deals with numeracy. Other parts of it deal with fluency. So it's very difficult to separate that out. So sometimes what they do is they do even odd, split half. So they have a much better feel that everything on the evens are going to be mirroring everything on the odds. Now the coefficient alpha is what we use to check the consistency, and unfortunately my alpha sign didn't come out right, so I will show you that in class. And it's used to check the consistency across items. So whenever you see that little alpha sign, it looks kind of like a little 8 on its side. We're talking about the coefficient alpha, and we're looking at consistency. Now a p-value must be below 0.5. Okay, and I will show you that on the tests. And often we designate that if we're looking at if we're looking at alpha, we know we're looking at correlation. If we're looking at a p-value, most likely we're looking at some other statistical test, but that you just have to know which tests use which values. Now, which type of reliability is best? We have basically 3 different types. We've got consistency over time, items, and consistency of scores. Our R-scores, now an R-score refers also to a Pearson R in particular. So it's a correlation, but it's a Pearson, okay? Which means that we have to have equal number of items, and we have several different expectations that are involved. And so if we have uneven numbers of participants, we will probably have to use a different statistical test. But a Pearson says, all right, we've got 25 in this group, and we've got 25 in this group. It's even. And so that's usually the best time to, you have to look at all of the different rules and make sure that you have the correct test being used. But when you see an R, like this one, italicized and small, lowercase, we're talking about a Pearson R, and it's really the easiest type to read. Very straightforward. 0.60 is adequate. 0.80 is good, it's preferred, but quite honestly, once you get past a 0.8, I like 0.85 for a better number. And which one you choose depends on the purpose of your assessment. So a reliability coefficient is a group statistic. You have to have more than one. You can't do it on just one person. You need at least 30 for it to be halfway valid. And it can be influenced by the makeup of the group. It can, and it's important that you review the manuals.